I will give a few words about the Green Computing Observatory. The Green Computing Observatory is a new part of the Grid Observatory initiative, and the reason for this new Green Computing Observatory initiative is that everybody knows that energy consumption is a massive problem for IT systems now. It's a very complicated problem. Why? Because energy usage in IT systems comes from multiple sources and finally can be considered as a complex system. In an IT room, you have many various control loops which are at work. The first one is at the motherboard level, where the IT manufacturers have already created intelligent monitoring systems and intelligent management systems at the cooling level and at the user level. So the problem for optimizing energy usage in IT systems is really a problem which cannot be solved a priori and which needs data. And our work with the Green Computing Observatory is first to collect data, to make them available for the wider scientific and engineering community, and that's the tradition, I would say, of the Grid Observatory initiative. And when these are collected, to try to interpret them. So what are we doing in practice? We are collecting data from a large computing center, which is namely the computing room of the Laboratoire de l'Accélérateur Linéaire. The Laboratoire de l'Accélérateur Linéaire has a large room with something like more than 2,000 cores, and we have developed a new monitoring facility which gathers data from very low-level sensors through the IPMI protocol. So I will detail what kind of data we get afterwards. And we get also data related to computing usage. That is what kind of job traffic, what kind of memory traffic, what kind of disk traffic we have. So collecting this data is not that difficult, because both IPMI and the software we use for collecting data for computing usage, which is Ganglia, is quite de facto standards. What was difficult and what was significant work was to integrate this data so that they make sense. When you get data, for instance, for watts which are used, or energy consumption, and when you get data from computing usage, you have to know that they refer to the same computer or machine. And defining exactly what is a machine, what are the precision, accuracy, and other parameters was significant work, and this has been performed in collaboration with a laboratory of Amiens, of computer science of Amiens, which ended up in an ontology. Now, what is the use of this kind of data? Let's get an example. Here we have a visualizer which has been developed by one student of our lab in Orsay, which is the Laboratoire de Recherche en Informatique. And here we have a visualization of the data we can collect. This is typically one worker node of the LAL site. Here, what do you see? You see Ganglia data, for instance. This is the load, the ratio of processes a long time. You have memory usage. You have power usage in watts, which correspond to a motherboard level. You have CPU activity here and a lot of other things. And here you have very specific and very low-level information, which is the rotational speed of the fans, which are the small fans, which are at the motherboard level. And just with this visualization thing, you see something which is not really acknowledged in general, I would say, computer science and engineering research. What do you see? Here you see the CPU usage. The CPU here is very high. At the end of the same week, it's very high. But if you take a look at the energy consumption, the energy consumption is at a certain level corresponding to this high level. And in the end of the week, the consumption is very high, much higher than in the beginning of the week, even if the CPU usage is rather equivalent. So this is strange. It shows that CPU usage is not the only thing and probably not the main driver of energy consumption. And if you have a look at the general plots which are here, it's not memory, it's not network, but the fan, rotational speed of the fan is going high here. So what is happening in fact is that the cooling of the room was not so good at this period, and the rotational speed of the fan was going high because it had to cool the motherboards. And here the explanation qualitatively of what is going here. So now our work, now that we are done with the work of collecting the data, we have a very difficult work ahead of us, which is finding models for interpreting this data. But this is very interesting work, and we will go on this work in the next week. Before we conclude this talk, I would like to present to our audience the guy who really did the work, who is Julien Auroy. He has been the main engineer in collecting and organizing this data, and many thanks to Julien, otherwise there will be no Green Computing Observatory at all.